Hi guys, welcome to my YouTube channel. In today's lesson, we'll be doing quantum numbers. So there are different clouds of property where electrons can occur around an atom. So electrons in an atom are described or characterized using 4 different types of quantum numbers. The first quantum number being principal quantum number, denoted as n. This determines the main energy level or energy shell in which electron is present. The azimuthal quantum number, or also known as an angular quantum number, is related to the shape. This can also be determined using n minus 1. The magnetic quantum number, this describes the spatial orientation of orbital in which electron is found. And then last but not least is the spin quantum number, ms. This is either one of 2 values, positive half or negative half. Positive half being a clockwise spin, negative half being an anti-clockwise spin. So with our quantum numbers, we know that we have a s orbital, a p orbital, a d orbital, and an f orbital. The s orbital is first level, second level p, third level is d, and fourth level is f. So our L, or our angular quantum number, in the first orbital is L, n minus 1, which is 1 minus 1 is given as 0. Our P, 2 minus 1, 1. L for D, 3 minus 1 is 2. L, 4 minus 1 is equal to 3. So this is how we get our values for our azimuthal quantum number, or also known as our angular quantum number. With our magnetic quantum number, for the first orbital it is 0. Our second orbital it's negative 1, 0, and 1. For our third it's given as negative 2, negative 1, 0, 1, and 2. And our fourth it's given as negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then for our ms, using the same type of levels, using the same level, we'll have 1, where our 0 is, negative 1, 0, and 1, negative 2, 1, 0, 1, 2, negative 3, negative 2, negative 1, 0, 2, and 3. Let us jump straight into our first example. We'll use the valence electrons for carbon, 2p2. So we determine N, L, ML, and MS. The 2 in front of the letter is our N. In the previous explanation, I gave you an example, an equation rather, that n minus 1 gives us our L. Therefore, 2 minus 1 will give us 1. For our ML, on the p orbital, we either have negative 1, 0, or 1. So this is what I personally use in order to determine the ML for the electron. So I'll draw something like this, and then with our exponent, it guides us to how many or how the electrons are drawn. So for our P, it's 1, 2, which is the 2. So we have 1, 2 electrons, and this is lying on the 0. So ML is 0. And then for our magnetic spin, I said that it's either we have a positive spin a clockwise positive half spin, which is clockwise, or a negative half, which is anti-clockwise. So with the electrons facing up, that is obviously going to be a positive half, which is a clockwise spin. Let's do our example 2, which is iron. Iron, let's do the valence electrons, 3d6. Okay, so we'll determine 2l, n, l, ml, and ms. Go ahead and pause the video and see if you can get the values by yourself. Okay, so let's just erase that quickly. Okay, so with our Ln, we know that 3 is our answer. N minus 1, which is 3 minus 1, which is 2. Which confirms our L being 2 at the D level. And then for ML, exponent 6, we go there, 6. So it's 1, 2, 3, 4, 5, 6, which lies on the negative 2 sublevel. And then for our spin, because our electron is facing downwards, our spin is going to be anti-clockwise. Okay, let's do our last example. Let's do fluorine 2p4. Okay, it's fluorine 2p4. Okay, N, L, ML, and MS. Okay, our N is 2, our LP, but let's calculate that. 2 minus 1, 1. Okay, ML, okay, that's raised 4. Remember, 4 electrons. So it's going to be 1, 2, 3, 4, which lies on the negative 1 subshell. Negative 1, and our spin, because it's facing down, negative half. And that is it for today with quantum numbers. I really hope that this video explained how quantum numbers are calculated. If you like the video, please push the like button and subscribe. Thank you. See you later. Bye.